good friend of mine. She's on our operating committee. Occupation, mechanical engineer, correct? And doing some wonderful things over at Stark State. And this is a pretty exciting session. Yes? You know what? I did not print off extras, but why don't you guys share, and then I will make sure I bring some extras next session. Okay? All right. Thank you. Okay. With that, I'm going to turn it over to Ms. Shear.
So I'm going to be talking about mechanical engineering a little bit and engineering as a whole. And then I actually brought some kits so we could do a little fuel cell kind of solar experiment later, if time allows. And if not, we can do it during the exchange period. So I wanted to just verify how much time do we have?
Now we're in 20 minutes.
Oh, we've got plenty of time then. So we'll definitely have time for an experiment then. And hopefully you didn't use it. All right, yeah. So you've met with a few engineers already. So you know that in fact, the definition by Webster's of an engineer is that engineering is the application of math and science by which the properties of matter and the source of energy in nature are made useful to people. Now, in fact, this is a very apropos definition because today I'm also going to be talking to you a bit about careers in the energy sector. So it's great that it talks about sources of energy right in the main definition of engineering. So really, engineers come in many, many different forms. As you've already seen, I think you've met at least 4 or 5 engineers already through the course of your studies here so far. But above all, what you'll find and what you've seen is engineers are really problem solvers who really make things and processes better. And if we can't fix it, we'll create something new. So that's another aspect of engineering. And the salaries, quite frankly, for those with a Bachelor's of Science in engineering tend to be extremely good. My career has been just an excellent process of continuous improvement. I have lived in 8 states. I have visited 5 of the 7 continents. It's been quite an exciting career. So I can say that engineering and particularly the bearing industry has been very, very good to me. And what you can also see is that depending on your level of education, and this is actually true of many different fields of study, the higher your level of education, typically the higher your wages are going to be. And the major disciplines of engineering, of course, are mechanical, electrical, chemical, civil, and industrial. But in fact, the engineering fields can cross into so many different areas, such as automotive, aerospace, agriculture, biomedical, computers, environmental materials, nuclear robotics, and safety, just to mention a few, but there really are hundreds of different ones. So today, I'm going to focus a little bit more on mechanical and mechanical electrical related to my own experience, both in the past and currently.
You just tap it, we're good.
Yeah. So this is where what I'd like to do first is to play the Career Day video because it was created by Timken and it shows very clearly many of the different aspects of engineering from someone who would be in the bearing industry. So let's go ahead and if for some reason the sound doesn't play, I do have speakers. I'll go ahead. which is the internet connection? Or is there an internet connection?
Click Firefox on the phone. Just click one of the boxes.
Oh, no, it says I'm not connected. Can we play this from the other computer? If I unplug it from the other?
If you have HDMI.
The problem is I couldn't open PowerPoint because the PowerPoint script was expired on this computer. So if you could switch screens, if you could pull up YouTube.
That's about all I know how to do. Bruce, your friend, the IT guy, we need him.
Yeah, and actually what you need to
It's
do also is
more
to buy
evident
a
than-
subscription to, yeah.
Sitting there going, boy, I wish he was in the room. Lunch next week? Good, okay. I'll be there.
Where's you two?
And so basically my mom
Good sound.
either gives kids shots or she gives them medicine to make them better.
Excellent job, class. So what did you bring to share with us today?
The world. It looks like a marble.
Your dad makes marbles?
My dad works for Timken. What is a Timken? That's a Timken.
How cool is that?
So that gave you a good view of where bearings are used and also a little snapshot of why engineering is so important to an industry. If it wasn't for the engineers, that helicopter wouldn't stay up in the sky. And that rocket would not have made it up into space. It took a lot of other fields of study to succeed in that accomplishment as well. They all work together. But quite frankly, without the engineers, it wouldn't have happened in the first place. So it is so important. So I'm going to be talking a little bit now about the specific field of energy, and as it relates to some of the curriculum that we have at Stark State College. As you saw from my bio, I'm the Director of Fuel Cell and Alternative Energy Technologies, and so that is my current role. What we saw from my past record is I've also had a very long career in the bearing industry, globally. So my master's is from the Rotterdam School of Management in the Netherlands. That was a lot of fun, being able to work and live overseas, and being able to manage a group of international employees from all different countries, testing and developing new products in the bearing industry. That was my career with SKF. When I came to Timken then, I moved on into product management, and then the management of the change, management of change group, which is so important. If you can imagine that you have one product being made in as many as 6 different factories, and that product could go into a Ford, a Chrysler, or GM vehicle that's produced in any one of those countries, and that product has to react and live and be sustained and strong, and meet the same warranty criteria no matter where that product is made. As well, every bearing has its own little signature. So if the product has a little bit of vibration in it, produced in one factory, the motor that bearing is in is going to have a different signature. So this is why standards and control and uniformity across the globe is so important. So that's why I was part of a global management of change initiative to ensure that if one factory that had the design control of a particular product was making a change, that every other division that was related to that product would know about that change, and everything would be coordinated so that they wouldn't have a tremendous amount of excess products that would be obsolete by the time the change was initiated, or certain components of that product would become obsolete and scrapped as that change was initiated. So managing changes is pretty important. But now I'll come back to my current role in Stark State College. So I am the Director of Fuel Cell and Alternative Energy Technologies. So within that role, we have supported many, many different initiatives. The largest being, of course, if you've been on campus, the building of the LG Fuel Cell Systems Prototyping Center. Today I'm going to walk you through a little bit about what that was about, and what that company does, and what kind of opportunities are there for engineers. Another large initiative that I've been part of for the last 5 years is the NSF Great Lakes Fuel Cell Education Partnership. This partnership is a collaboration among 6 different schools in 11 states to develop the engineering curriculum for fuel cells and electrochemical processes, so that the engineers of today can meet the needs of industry tomorrow. Other projects that we've been engaged in are within the Department of Energy, the Department of Defense, and then, of course, the Wind Energy Center, the Timken Technology Test Center that you'll see up near the airport when you're driving up Frank Road, and ShaleNet, which is in the oil and gas industry. Okay. So our current profile in energy today is such that you can see our supplies come predominantly from oil and coal and natural gas, certain percentage of nuclear. Then in the renewable energies, we have the groupings of hydro, wind, solar, biomass, and geothermal. Now, this is America's profile as a whole. If you look at the Ohio profile, it's a bit different. You see a lot more coal in that mix. And what you also see in our forecasting of the energy profile is that the demand for energy is ever increasing. And the problem is, the challenge is that we want to be less dependent on foreign oils, but at the same time, our demand profile is increasing. And we also know that ultimately, fossil fuels are actually finite. And we're consuming them at a rate that is greater than the Earth is restoring them. So we need to look at alternative energies. And fuel cell technology is one such means of conservation. Now, if we look at the Ohio profile directly, you see coal-fired burning plants stand out dramatically as far as what where's our energy coming from here in Ohio. Next, you'll see the natural gas-fired generation, and then thirdly, the nuclear. Those are the kind of the big three in Ohio regarding energy production. So overall, our generation actually shifted a bit from that earlier slide, which I think was from 2009. 2011, we're at 77% from coal, 11% from nuclear, and 9% from natural gas. And I have to say, as you all know, we're in the mecca of natural gas, so you're going to see that number increasing. One of the initiatives in the state that's driving careers in alternative energy, as well as improving our profile of our energy generation, is the initiative in the state that will be at 25 by 25. You'll be hearing a lot more about this during the next years, but this is actually what is helping to drive as well incentives for industry to move towards renewable and advanced energies. So the plan is that by the year 2025, 12.5% of our energy generation is going to be from renewable energies, and 25% or 12.5% would be from the advanced energies. So this will ultimately lead to a better use of our resources, less use of the resources that cause other problems such as emissions and so forth. And it will also give us much more security because we'll be moving from centralized large plants transmitting power over long distances with losses to decentralized resources that are smaller plants serving a network of areas within the state. Because of these changes, there's tremendous new job opportunities for all of you as you go on to your engineering degrees or IT degrees or other types of degrees related to the opportunities that will be coming in this power industry. Yeah.
Excuse me, I'm familiar with most of the terms on this slide except for cogen. What does that stand for? Cogeneration is
when you actually have two processes working at the same time. You know, I can pull specific references for you to show you specific examples.
All right.
There's not really time to go into that
That's
right
fine.
now, but we will. I can
Okay.
send you more details on that.
Sure.
As a little bit of an example, we have systems that are combined heat and power. So you can have systems that are actually performing two energy tasks at the same time.
Oh, so one's sapping up like the heat entropy of the other or something like that.
Yeah,
Okay.
so you can actually, and when I get to the LG fuel cell system, I'm gonna actually explain such a process as
Okay.
that, where you have a high temperature process that yields heat in the process that then is reused within the process, or it can also be used for other productive means. So now I'd like to talk about some of the different areas of the campus where we're training and developing the engineering in different fields. So this is the picture of the Technology Test Center that's at the corner of Schuffel and Frank. How many of you have driven by that? Anybody notice it? Okay. It's really...
How many of you have been to the Stark State campus? Raise your hand.
Okay. How many of you have been in the fuel cell center? Okay, handful. Okay. Yeah, I won't be going inside that center, but I'll actually be telling you more about that center as we go forward. So at the Technology Test Center, it's a collaboration with Timken and Stark State. And at the upper level, which you see from the parking lot, we have a beautiful lab and classroom and conference room for holding classes and also being able to have meetings and so forth. And in the lower floor of that building, Timken has a MTS machine which can do dynamic loading situations on the main bearings for large wind turbines. Wind turbines in the size range of producing 2.5 to 3 megawatt plus power. So it's a very large machine. And the whole building actually was built around that machine. And a couple of weeks ago, or maybe it was a month ago, you saw some of the large construction projects that one of the engineers that presented was a part of. The infrastructure for this building was that much of an engineering feat as well, because they had to put in the supports of what would be just like building a 3 to 10 megawatt scale wind turbine. So the rebar and the construction for the support of that machine was an engineering feat in itself. And the reason why all of that rebar and construction was necessary was that machine had to be totally separate from the whole building. Because otherwise, when you put a load on something, you have an equal and opposite reaction load. Which means that all of those loads on that machine have to be taken up to the ground and separate from the building. Otherwise, the building would fall down, being cycled and cycled so many times. So this was really quite an engineering feat. If you go to the Stark State website, you can actually see pictures of the construction from the start to the finish. But we're not talking about construction today, so I'm going to move on. Now, this is why that machine was built. If you look at the sizes of wind turbines over time, you see a marked increase in the size of those wind turbines. And in fact, when you get above a 2.5 megawatt scale wind turbine, that's when you start to see tapered roller bearings as the main bearings in the turbine. And that's why Timken was very interested in developing the best bearing in the world for this application. So this picture kind of shows you what those different types of bearings are depending on where you're at. So in the smaller range, below 2.5 megawatts, you see a spherical roller bearing as the main bearing. And a spherical roller bearing has rollers that look like little barrels. And the raceway is curved over those curved rollers. And the reason why that bearing is popular in those size ranges is that one of the advantages of a spherical roller bearing is that it can take dynamic misalignment. So the bearing can roll, but also take those shifts that occur because of the loading and the variability that happens when you can imagine the gusts of the wind is changing. So that's why spherical roller bearings are so popular in the lower sizes. But it's a blessing and a curse that it can do both, take the loads and be dynamically misaligned, in that whenever something misaligns as it's rotating, you have a little bit of sliding. And because of that sliding, you have wear between the two components. And so for that reason, when you get above the 2.5 megawatt, you start to see loads which this type of bearing just can't handle that kind of loading. So you need to take those loads in a better way and assure as best as possible the true rolling, because with true rolling, then you have the lubrication between the meeting components, and the bearings can live that much longer. And of course, these turbine, the nacelle of the turbine can be 325 feet in the air. So you certainly don't want those bearings to fail and have to come in with a helicopter and some very incredible wind cowboys to come in to disassemble the motor in the air and bring it out, or worse, have to remove the whole nacelle, carry it over, bring it to the ground, and then do maintenance. It's not very economical. So you want those bearings to go, to run for 30 years without any failures. So you can imagine that not only is it important to have the right product that takes engineering know-how to understand all of the loads and the situations that that bearing is going to see, but also the right preventive and planned maintenance on that product so that it's not going to fail after the 5th year because you forgot to grease it, you forgot to lubricate the components. No, it's very important. Now this is a picture of some of the types of equipment that we have in that technology test center. You see on the left is a wind turbine simulation machine. In fact, it's basically a robot that looks like a wind turbine. Because of course we are not driving the system by the wind. Instead, we're driving it by power so that we can see how all the components work. So if you put energy into a motor and drive it, like for instance from the wind, it becomes a generator. If you take energy from the motor, then it's basically the motor. So, so here we are basically running a wind turbine that is a motor because we can't have the wind to be able to rotate that on the inside, but we can simulate all the components and understand the process. So here, instead of generating energy, we're actually using energy, but at least you get a good idea of all the components that go into the construction, the gearing, the yaw mechanisms and pitches for the blades and so forth. And on the next picture on the right is a general purpose electrical trainer, because in the wind turbine industry, it's critical that the technicians understand alternating current, direct current, and all of the different switches and controls that are related to transmitting and generating energy. So I told you that I'd speak a little bit about the fuel cell center. How many of you, or does anyone here know what a fuel cell is? Yeah. Jordan, do you want to?
Isn't it kind of like it harnesses like hydrogen? It's kind of an energy source.
It can. A fuel cell is a means of producing power electrochemically. So we'll get a chance to do some hands-on experiments as I finish the presentation. Now, our relationship in the fuel cell industry actually dates back to 2003. Some of you have been to the prototyping center and the fuel cell center. What you might not know, if you haven't been to LG Fuel Cell Systems, is that attached to our fuel cell lab is a whole factory, a prototyping center that's actually building a 1 megawatt scale solid oxide fuel cell system. And I'm going to be showing you in a little bit exactly what a fuel cell system is and how it works and how the different technologies work. So this relationship started back in 2003. And at that time, the state realized that if we do not go forward with supporting emerging technologies to improve our energy efficiency, then we are really going to have a huge problem in the state. Because we are a huge manufacturing state. We use a lot of energy. And because we use a lot of energy, we emit a lot of NOx and SOx and CO2, or carbon monoxide and so forth. So we really have to be careful to preserve our environment. So what happened was the state said, okay, we're going to fund and support public-private partnerships. So we built a prototype